Hello builders. So this is going to be a special video, all right? Slightly different to the ones that I'm used to doing in this channel, because in this video, I'm going to go through the 16 months that I spent building AI systems for myself, for my agency, and also for my software company, for my AI software company. And I'm going to be discussing tips and tricks, fundamental concepts, and everything between that you need to understand in order to build AI systems that are valuable for yourself and also for your clients, right? So let's get straight to it. So I think the wise place to start is to show you some of the stuff that I built for FG Labs. So I've built conversational chatbots, conversational agents in BotPress, conversational agents in VoiceFlow as well. Here you can see a complex workflow that I built for one of my clients. Here you can see a simpler one. Here we have a pretty big one. And believe it or not, this is 1/3 of the whole workflow. And this was an appointment setter I built for a real estate agency. I've also built voice agents on Bland AI and on Vapi, as you see here. This is an example of an assistant that has access to 3 tools on Make to book calendars, get the current date and time, and so on and so on. And whilst I was building solutions for my agency, I've also built on my AI software company. And the goal with this company is to bridge the gap between data and insights. So currently we are at the demo phase. We are getting on demo calls with people that will be interested in the product, and then getting their feedback in order to improve the product. And yeah, so the reason I told you that is because I really believe that from my experience on the past 16 months and including the things that I've shown you that I've built or that I am currently building on, I think I can definitely provide you some value that you can then take away to build useful stuff, right? And throughout this video, we're going to answer this question: how can AI agents help businesses, right? Because this is not a simple question that I can just give you within a few bullet points, right? To be able to answer this question properly, we have to go through some core concepts that are used to build systems, right? Using language models. So we're going to go through that. And I think the best way to start is by introducing the basics, okay? Because we're always discussing all the complex things that we can build, all the amazing tools once they're finished and so on. But I think it's really important to go back to the basics, all right? Being able to understand the basics would allow you to then build on those concepts. And then whenever you have a complex system that fails in some way, you will be able to understand why it fails, okay? So yeah, understanding the nature of language models and how they fall into these larger systems will definitely help you with problem solving, right? In the case that you actually have to get a problem from a user or from a client and then build a solution out of it, or troubleshooting an existing system that you have, right? So given the situation, you need to understand the basics, right? And we're going to go to the basics of the basics, okay? Because some of it might not be that straightforward, okay? Because you get thrown with many different terms online, agents, assistants, and so on and so on. So let's go through it step by step, and we'll build it as we go, all right? So what are large language models? Well, these are programs that have human language as an input, and then we generate a text output, okay? As simple as that. But what's what makes these large language models so powerful? Well, sure, they understand human language, but they understand the semantic meaning behind human language, all right? What do I mean by that? Well, if I tell you that the movie was great, what does that mean, right? On a scale 1 to 10, where would you put the word great, right? So depending if I answer that question or if my friend answers that question, we're going to put that on a different scale, right? In that 1 to 10 scale, on a different part of the scale, right? And that's what semantic meaning is, right? Understanding kind of the abstract concepts behind the human language, right? And this is what machines struggled before, right? Before language models existed. Machines struggled with understanding these concepts. And now, with language models here, we are able to build amazing things because we're able to understand this semantic meaning in the human language, right? And then we have examples like ChatGPT, Google Bard, Claude that are able to do this very nicely. And here's are some ways in which we use language models, right? Q&A, summarizing text, generating code, because code is also text, right? And yeah, as I said before, well, not before language models, but a few years ago, it was really hard to build and use language models and integrate them with other applications, right? We had to use libraries like TensorFlow and PyTorch and pretty much hardcode most of it. And that's when LangChain came and it made life easier for all of us, right? This is an open source framework built on JavaScript and Python for now. And what it allows us to do is that it allows us to chain language models together with tools and actions, right? Think about it as a cascade of actions, right? It goes from one point and it finishes on another point. And thanks to that, we're able to add or chain language models together to be able to perform tasks of more complexity, right? And essentially what that allows us to do is to build applications that resemble real life things, right? Stuff that happens in real life in businesses, okay? And yeah, it has to reduce the barriers to do this. So God bless LangChain, definitely. And just for you to understand where LangChain lies in all of this, you have to understand the different levels of abstraction there are, right? The different ways in which we can communicate to machines. So down here, kind of the most fundamental level, we have CPUs, GPUs, and storage. And then we're able, CPUs and all that, CPUs, GPUs, and storage are able to communicate between each other using an operating system, right? And then some smart people decided that, well, we can actually communicate with the operating system using binary code as well, another types of code, but they all fall in the same level of abstraction. And then some other smart people came by and they said, well, can we resemble this to the English language so that it's easier to program and encode all this stuff and communicate between machines in an easier way? And that's how we came with all these programming languages, right? And then some other people said, well, I'm using the same 40, 50 lines of programming language to build something from a specific application, let's say for data analysis. Why don't I bundle these 40, 50 lines of code that are going to be the same every time I build a similar application and add them to a library, right? So now I don't have to write these 40, 50 lines of code again, right? So that's what a library is. And a framework is essentially something similar, but for building applications, right? And that's what LangChain is. It allows us to build AI-powered applications quicker, right? So essentially, this allows us to program more effectively and more efficiently and in less time. And then we have these other abstraction layers, and then we get to the application level, okay, or layer. And this is where most of us are when we build chatbots, agents, automations, and so on, right? Make is an application, N8N is an application, Instagram, Facebook, YouTube, right? And my software as well. So I think it's good for you to just consider what all these are, especially where LangChain lies and how it helps programmers, right? And where Make, N8N, and all the applications that you use stand by, right? It's in the application level. And funnily enough, Make, N8N, and all these applications that have AI modules in them, most of them are probably using LangChain in the background, all right? So I think this is pretty interesting and somehow useful to consider, right? But anyways, what can you build with language models using LangChain? Well, you've probably built stuff with N8N or Make or Zapier, for example, right? So this shouldn't be very mysterious at the moment. But yeah, conversational chatbots, agents, systems, basically anything that involves language model inputs. Language input, sorry. Now let's touch on the LangChain Basics, so the core concepts that you can build applications with using LangChain. And the reason I'm explaining this is because I want you to have an unbiased way of calling all of these different parts of an AI application or AI system, right? Because in YouTube or wherever you are, when you hear about AI and people talking about AI, you get thrown with different concepts and words, right? Assistants and so on and this and that. So I want you to have an unbiased way of calling all these things, right? What is a better unbiased way of calling things than going to the actual framework that all of these things are built on, right? So we're gonna go through these concepts. I think I just laid out 2, so it's not too many. So we have the concept of chains, and chains are basically just language models and tools just placed one in front of another, and they basically all work together to achieve a result, okay? Especially the language models. So the concept of chains is specific to the language models. So the thing to understand here is that you can make a task, a complex task, that involves language models chained together so that the input of a language model is an output of a previous language model, right? And that way you're able to perform complex tasks. Okay, and you see some examples here, but don't worry, you don't need to really focus on that. You just need to understand the concept for now. And here I have a resource that I will put in once I share this. I will share this presentation and you will be able to click this, okay? And this takes you to a mini course that these people have prepared so that you can understand this further if you want. But yeah. So as I said, you probably have seen this before on Make. So I'm going to show an example really quickly. And this is an example of a Blend AI component of a bigger system. And what this does essentially is it gets a transcript. We pass the transcript onto this language model. And then this language model is going to say, well, is it qualified or not? So it's going to spit out a yes or no. And that yes or no is going to be used in this language model and create an email, right? So if it's a yes, it's going to create one email. If it's no, it's going to create another type of email. And that's the concept of chaining, right? So chaining multiple language models together to achieve a more complex task. But remember, these are in cascade. So it goes from one way, it starts on one point and it finishes on another one, right? So it has a flow, it has a predictable flow to it. And now we have agents, okay? So let's clarify what an agent is once and for all. So an agent is a language model that has tools, right? But that's not all. This language model with tools can make decisions. So it acts as reasoning engines. It can reason what tool to use based on the query it received and the environment it is in, right? If you define it. And that's what makes it an agent. It can reason what tools to use on a given situation, right? So as I said, it can interact with tools. It's autonomous, so it doesn't need constant human input as you would have with a normal or a basic conversational chatbot where you're just chatting to it, it's giving to you an output back, right? It's a bit more than that. You give it a task and it will achieve it without annoying you back with further inputs that it needs, right? And as a consequence of that, some agents are able to autocorrect themselves if any errors appear, right? So inside the agents term, there are different types of agents, right? We'll see that on NA10 because I prepared a little tutorial or a little demo that we can go through. And over here, you will be able to understand what types of agents are there. Right. And now we have an example. If you know that wasn't very clear, we're going to go through an example on what makes an agent, right? So a person's going to come and going to say, well, going to show me a graph of the performance of Apple stock from the last 6 months. Okay, so we have a couple things going on here. I wanted to show me a graph and I want it to be a viable stock from the last 6 months. So there's a bit of complexity there right now that a conversational chatbot will not able to do, because first of all, it doesn't have access to tools, and second of all, it can't reason and choose the required tools. So first, what's going to happen is that it's going to check for the current date and time. Okay, this is something that most solutions that you guys are building need anyways, because all these language models have a cutoff date, right? At least for the latest ones, it's like, I think it's 2021 or 2022, I think. But yeah, it always should check for the current date and time, since it's not an inherent feature these language models have, right? They can only access, without any external connections, they can only access their training data. And that has a cutoff date. So they're going to access the web API, get the current date and time, and then it's going to say, well, today is the 7th of September. So 6 months back means that we're going to search from March to September. Okay. So it does search all that, right? And then it searches for that data from Apple stock in this API. And then once it has that, it's going to use that data and generate a graph, right? So it's a multi-step thing. So it's able to achieve all of this without further human interaction, right? We tell it once, and then it's going to perform all these tasks autonomously. And that's what makes agents so powerful. They basically act like humans in some way. Right, and now we get to RAG systems. So RAG stands for Retrieval Augmented Generation, and it's basically a technique to counteract a limitation that language models used to have, okay? And this was the fact that language models could not access, didn't have access to knowledge bases outside of their training data, okay? So whenever you ask a language model that's not connected to anything outside of itself, you probably got something like, as of my training data, I can't give you an answer, all I know is X, right? So attaching a RAG system on it would allow the language model to have knowledge on a specific domain, right? Or a specific set of files that you give it. So we're storing this information in the vector store, and then we retrieve the relevant info to the user. It's going to become clearer now, okay? Don't worry. And it combines 3 core elements, all right? The embedding model, the vector store, and the actual language model, okay? Not an agent, a language model. And you probably have seen RAG already. So whenever you upload a file on VoiceFlow or BotPress, you have actually used RAG, right? You have uploaded your file, your text file, or your PDF or your image into some sort of vector store, right? So there you go. So that's where you have seen RAG models or RAG systems. And this is a RAG system with which we can do question answering on top of a series of files or data that we first upload to a vector database, okay? So these files or texts get turned into vectors, similar to how we're doing here, right? And an embedding model turns text into vectors, and then those vectors get uploaded onto this database, right? And they look something like this, okay? All the words in those files are gonna be clustered together, right, by similarity, same as happens here. So this is the animal cluster, and this is the fruit cluster, for example, so that when we ask a question, we can ask that question, turn it into a vector, and now that those vectors that represent the question can be placed on this graph, right, or chart. And now what we're going to do is we're going to pick the nearby neighbors, right, of those vectors that represent the question. We're going to pick those, and we are going to push them back to the language model, and the language model is going to process that and gives us an answer, right? What we have essentially done there is just pick the most similar words associated to the question, right? And we retrieving it back. Hopefully that made sense, but if not, you can always check some resources that explain in depth how this works, right? But yeah, let's continue. And yeah, you can read this, but I think I've explained it, right? And the point with this also that I wanted to make is that RAG does not equal AI agents, okay? RAG systems are designed to only enhance the language model with additional knowledge, right? But they're not autonomous, right? They don't solve complex problems. Their goal, the goal of a RAG system, is to retrieve additional information from a database, all right? And enhance the language model's knowledge. If you want this to be part of an agentic framework or part of an agent, what you would do is remove this poor guy. You would add a language model, perhaps with other tools, and you would turn this whole RAG system into another tool, right? Now we have an agent, right? So what I'm essentially explaining here is that RAG can be part of an agent's tool, okay? So that's my whole point on this. All right, and now that you understand these concepts, including AI agents and RAG, now I can present you to the concept of multi-agentic systems, which you've probably heard of before, but if you haven't, well, this is basically the AI agents that I told you before that are able to think for themselves, they're able to use tools, right? And they're able to perform relatively complex tasks, but now we're putting them together in a group so that they're able to chat to each other and perform much more complex tasks together, right? And this is definitely, I think, the path that we're heading towards in the future, right? Multi-agentic systems. Because essentially what you could ask to this multi-agentic system is to create me a game from scratch, right? Or create me software, an entire software by scratch, right? So you would have an AI agent that is a programmer, another AI agent that takes care of the product, another agent that takes care of the marketing, another one that takes care of the infrastructure, for example, right? And they all work collaboratively together to build this app or software, right? And I think in the future, this is going to replace a lot of teams. So just imagine how important this is that Microsoft decided to come up with AutoGen, right? So this is how crazy it is. Then we have others like ChatDev, and then with Stack AI, you're also able to build multi-agentic systems, right? A bit more visually, which I like. I love what they're doing. I tried it and I think it's great, but yeah, it's a bit expensive. So it really depends how much budget you have. You could go with this, but yeah, these two require code, right? But anyways, you get the idea of this. And one important consideration that I realized when building multi-agentic systems with my team was that if you have a large language model and you tell it to do 3 different tasks, right? Let's say you give it the ability to do 3 different tasks. That agent is going to do much worse at doing one of those tasks compared to a smaller agent or language model that is only able to do 1 task, right? Let me explain you what I mean in a drawing or an illustration, okay? So we have a large language model here, okay? And let's give it the ability to be able to write me an email, write me a blog, and also write me some specific code, okay? I don't know what type of code, but some specific code. And then we have a smaller language model that is able to only write me an email, okay? This larger one is going to be much worse at writing an email compared to this one, right? Which is going to write it much better. And the best way to think about this is think about agents or language models as humans, all right? If you train one human to do either emails or blogs or codes, it's going to do much worse at writing an email than someone who's only been trained in that span of time to only write emails, right? Does that make sense? So that's that's something that I realized. And what you can do then, if you understand that this is the case, then what you can essentially do is, let's see if I can get it here. You can have 3 smaller specialized models, right, that each do the different tasks that the bigger language model can do. And then you're going to find out that all of these specialized smaller models are able to do these tasks much better than this bigger one, right? Which is really nice to know. And you know, if you want to ask this framework to do either of them, then what you can do is you can connect these to another language model or an agent, right? In this case, you can call it agent, to decide what model to call, right? So this is a really good approach to building robust applications, right? Given that the tasks that you're placing here are not super related to each other, right? Because if they are super related, and you do need to retain the context, because from here to here, you might lose some context, right? Whereas within a language model, within a single language model, you're not using any context because you're not passing any messages from one language model to the other, right? But if that's not the case, if the tasks are mildly different, then you can use this approach to get better results, right? I don't know exactly where you're going to apply that. If you program, then that makes sense. And if you build multi-agentic systems, that makes more sense. Well, you can actually build these on NA10 or Stack AI, actually. You can choose probably the model size, if I remember correctly. But yeah, that's a very important takeaway that you should take with you when building and designing multi-agentic systems, right? The size of the model and the type of tasks that they're doing, and see if you can organize them in this way, right? And you find out that they can end up doing they can end up performing much better, right? And obviously this depends on the dependency of each task, right? And how much context do you have to have from one task in order to do the other one, right? This all really depends, but that's something for you to try, definitely, if you are building these type of systems. And this is a big one, right? I wanted to clarify this. So AI agents and AI automations are different things, right? You can make AI automations act as AI agents, right? But the way it's portrayed out there, the way it's actually done and shown on YouTube videos, is that AI automations are simply kind of systems that do specific and repetitive tasks, right? They reach from point A to point B, okay? So similar to what's happening here, right? I'm going from point A to point B. There's no part in the system in which we allow one language model to just perform multiple tasks, right? You can essentially tell the language model to spit out a yes or a no or a maybe, and then have 3 different routes that if the language model says yes, well, it's going to do that. If it says no, it's going to do that, right? But that's embedded within the automation, right? It's not part of the language model, if that makes sense. The language model, it's kind of different, okay? Because that's built within Make, for example, those filters. So it's not the actual agent triggering them, if that makes sense. But yeah, so it reacts based on predefined workflows, right? We are defining all of that. But AI agents can make decisions and take actions independently, and they do adapt to new situations, right? And most importantly, they also learn from interactions, right? Which is what these completion modules cannot do. These are input-output, but they don't learn. They don't get better as they go, right? They get better if you write a better prompt, but that's about it. Right, so hope that was clear. And once again, well, why are agents a big deal? I'm probably repeating myself a bit, but they can handle complex human tasks, right? And the second point is kind of the same. But yeah, they speed up processes that require manual effort. I mean, this also happens with AI automations. And yeah, they enable humans to focus on creative and strategic roles. I guess this is not really unique to agents, but definitely agents can help in many places that AI automations cannot, right? I'm not telling you that AI automations are worse than agents. I'm just telling you that they are a bit more advanced, right? And if you combine these agents into groups, that's where the real power lies, as I explained before with the multi-agentic systems, right? But anyways, you can skip this slide. But anyways, I think it's time to build your first agent, okay? And remember, AI agent is not doesn't necessarily mean it's an AI automation, okay? Just for you to know. And you might think, well, do you need Python, use IDEs, no front end, host on servers, etc.? Well, you don't need to, because we have tools like N8N, right? And you might think, well, what's so good about N8N? Well, the good thing about N8N is that the way it's built, it has an AI agent set of modules that are going to show you how LangChain, AI agent components in LangChain work, which is very, very helpful. Make does not do that. Zapier does not do that, right? They're too abstract. They're too abstract for you to be able to see the components of an AI agent, right? But this does, right? I'm going to show you. And the good thing about this is that all of the logic can be handled inside N8N. So inside N8N, you can build the AI agents as well as triggering some automations and workflows, right? Whereas with these tools, you'd have to possibly connect voice flow with Make, right? And that would technically be an agent, right? But you have to connect two platforms together, right? VoiceFlow, WordPress, or you know what I mean, right? So getting the conversational AI chatbots together with AI automations, okay? Voice agents, they're definitely agents, right? Because they have the decision capabilities a bit better defined. But yeah. But with N8N, you can definitely see the different components that make a real AI agent. And now I'm going to show you an Airbnb chatbot that I've built on N8N, okay? So let's go ahead and look at that. All right, so regarding the AI agent components and so on, this is what I explained you about, right? So this is the AI agent, and then you're connecting the chat model, then you're connecting the memory, and you're connecting the different tools that I can use, right? The vector store tool, the Pinecone vector stores, right? So this is essentially the RAG I showed you. Well, part of the RAG system that I was showing you. And you see here it's being used as a tool, right? What's going on here is that we are using this agent and we are retrieving important information whenever the agent needs to answer questions about the Airbnb, okay? So I have something here on the background, right, on another workflow on N8N. And what happens is that right now it's just on test, right? So I need to click this for it to work. But what it's essentially doing is it's going on my Google Drive and downloading a file onto a vector store, right? And then it's using an embedding, as I told you before, in the rack section, and then it's using all of this to store, convert that information into a vector and storing it into this vector store, right? And once that's there, then we're able to use this as a tool, okay? So let's chat to it, okay? So let's see what it says. So hi. Right, so what I gave it was the following. Right, you might remember this from another video, right? So the Airbnb policies. So I'm going to ask it the checkout time, and I'm going to ask about the house rules. Okay, let's see if it knows about it. So let's go back here. Oh, time should I leave the Airbnb for checkout? Right, so you should plan to check out of the Airbnb before 11 a.m. local time, right? And the cool thing is that you see on the right here, you're able to see all of the steps that are happening, right? So, for example, here, I'm asking it, what is the checkout time at the Airbnb? And we're seeing here how it's converting that into vectors, right? So we are able to see this visually. So the level of control that this has is really close to what you would have if you're programming this using an editor, right? A Visual Studio, for example, using Python, right? And this is probably the closest that it gets to that. So that's why I'm saying it's abstract, but not too abstract, right? Like Make or Zapier, where, you know, it gets too abstract that you can't even see this stuff, right? You can't even see the embeddings working in the background. You can't see a log of that. So that's the power of this. And then you can see the actual system messages and the stuff it's being added on the model and so on. So you see the buffer memory working, and yeah, so you're able to see everything, which is great. All right, let's ask something else. So let's ask what are the house rules? Right, so here are the house rules for the Airbnb property: no smoking, no parties, and so on, right? And you can imagine how you can connect these to tasks, these to other tools, right? Maybe you want to connect it to, let's say, search API, similar to how you do on Make, for example. And let's see what else. You have Wikipedia as well, right? So we can trigger that. Who is, I don't know if I spelled correctly that. Well, let's say who is Michael Jackson, right? Right, and now you see that I use Wikipedia, right? So we queried Wikipedia, and then we're retrieving all of this back from Wikipedia, but then we are processing it a bit more so that we get a better answer, right? A condensed answer. So there you go, right? We just use the Wikipedia tool and we can see that it's being used. Now we can possibly use the calculator. These are really simple. Tools, right? So the calculator, but you could imagine you can attach other tools, right? So let's see what tools it has. Well, you can, for example, look at this. Look at all the things that it can connect to, right? It's pretty much. So the great thing about NA10 is that, probably I mentioned it before, but I'm going to mention it again, is that you can use AI agents. You can build AI agents as you would in code, right? Because you can see you have full control all of the different components. But you can also use these AI agents within an automation framework, right? Like Make, for example. So you know you can add different actions to do, right? You can transform data and so on. So that's the power of NA10. right? And you can build really complex systems with this without having to rely on 2 apps at the same time or 3 apps at the same time, okay? There's of course different pros and cons with an A10, right? For example, because it's an AI agent, you wouldn't have the flexibility that you would have when you build a conversational agent in BotPress, for example, where you exactly understand how the conversation is going to go. But yeah, there's pros and cons, so it really depends on your use case, right? But if you really don't mind about controlling too much of the conversation, then you can definitely have something like this, and it's going to help a lot. And the way you set up the Pinecone vector store, right, and the way you upload files, at least how I did it here, is that you obviously need to go to Pinecone, right? This is where we would create our indexes inside a vector store, right? And a nice way for you to upload this is by creating a separate workflow that I showed you, right? You would go and do some authentication, right? Like you would do with Make, for example. You would choose File, Download. You choose the file itself. You can also choose folders, right? So that, let's say you keep uploading files to that folder, you can automatically trigger this so that it gets uploaded automatically to Pinecone, right? So obviously it takes some more time and expertise and kind of knowledge to be able to build these solutions. But the good thing with this is that if you're looking for that flexibility that Make and Zapier doesn't allow you to have, then you can build here, right? That's all it is. And then I have here WhatsApp. So yeah, I have a WhatsApp chatbot as well, but I don't want to get into the details on how to set this up. I was thinking to make a separate video on that. If you wanna see how to build a WhatsApp chatbot on an A10, please let me know down in the comments below. I'll be really happy to do that. But I need to see if people would be interested in that, right? But yeah, it's a really cool app. As I said, I didn't try it for long, right? But it seems great, and it definitely has a lot of capabilities on it. So yeah. So yeah, that's the demo. And I listed the different AI no-code tools that you can use, right? And their limitations. So this is a conversational AI chatbot that can be turned into an agent if we send JSON APIs. If we send, we make API calls to other software such as Make or Zapier, or to another server that can perform a task over there, right? But natively, it's not able to do a lot of tasks by itself, right? So that's why I was saying that, you know, N8N basically is VoiceFlow and Make combined in some way, right? But yeah, voice agents are able to do that. They have that autonomy to just trigger tasks easily or easier. But yeah. But anyways, I want you to be aware of the adoption of agents in enterprise and AI systems. Deloitte, JP Morgan, Lenovo, all the big companies are doing that already. It's like a race to see which companies actually integrate these faster into production, right? But the only thing I want to point out here is that we are here. We are at a really low market cap at the moment, right? With the adoption of agents in the market. So we have this kind of parabolic curve that we still haven't touched on yet. So just to let you know, you're still early. So as long as you understand what I've mentioned in this video about AI agents, you're doing already really well, right? You're definitely in the top 10-20% of people, just by knowing that these things exist. So So yeah, so it's good to know. It's good knowledge, understanding agents and the capabilities, because you can capitalize on it, right? If you're early on the market, you can capitalize on that straight away by building tools on Anytime, or as I said, connecting stuff on VoiceFlow and Make, and building it to however you want. But as long as you act on it right now, you're in time and you're up for a big chunk of the market, that's for sure. You're still early. And now I want to touch on some considerations when building AI solutions that are high quality, okay? First of all, data is king, right? If you want to have an AI system that gives quality outputs, you have to train it on the right data, right? You have to give it good examples, right? The data that is, maybe it's retrieving data from somewhere to be able to generate a query or an answer. That data has to be high quality, right? It all lies in the data that you feed the language model. If it's either for training or as an example, or if it's using that to process some other parts of a task, right? Data is king. And then you have to worry about prompt engineering, because one of the reasons why your agent is not going to perform properly is because of the prompt you give it, right? Super important to know how to prompt these language models and agents. And this is a framework that you can follow as the system prompt for your language model, okay? Role, objective, tools, instructions, right? About the tools, they have to be detailed and concise, but that pretty much applies to everything, right? Detailed but concise, don't fluff, because when you fluff, the language model is not going to perform as good. The way you want the stuff to be outputted and formatted. Examples, very important to give it examples, and then additional notes. This is specifically used for tweaking the language model's output to how you want it, okay? I'm going to show you now a prompt here that I have for a clinic. So you have here the system role, okay? Then you have the objective, right? What's the objective of the language model or the agent? Then you have the tools that it's allowed to use, and then the instructions, right? What can it do, right? With the tools that you give it. And you see here that I'm not being fluffy, right? Ask for the caller's first name, inquire, use the provided visit times. But you see also I'm giving it enough detail for it to act, right? So you got to find that balance between detail and conciseness. Right? And then I have another instruction for another task, output requirements, examples, right? And then a little reminder, a set of reminders at the end. So this can be used in order to tweak it. So let's say you try the agent, you test the agent's output a couple times, and you see something is not working. Well, the reminding section is for that, right? If it forgets something, you can just let it know, right? Right here, so that you don't have to really change the main structure of the prompt if you don't want to, right? You can always tweak it at the end. So those are the little things that I learned regarding prompt engineering, which I think is, as I said, one of the most important parts when building a solution. And some other useful things to know are how to integrate with other applications through APIs and webhooks, for example, right? So the first method to connect to the first main method to connect to a software or an application is through an API call, right? You need to be aware of the two main methods that you're going to use, get and post. Get is to retrieve something from a server, some information, and post is to send the information to that server, right? If you wanted to process something, right? When I say software, I mean, or app, I mean a service, right? A service that you're using to perform or achieve an action, right? For example, I'm sending data to Data for SEO. I wanted to scrape stuff for me, and then I wanted to retrieve back some information, right, as the top 5 searches. Or I'm sending data as inputs on a post request to Apify. It's going to do some web scraping for me, and then I'm retrieving that information back, right? So first we're doing a post request, right? And then that service is going to perform all the things that it needs to do, and then it's going to retrieve me something, right? Which you could add a get request at the end to retrieve that data if it doesn't do it automatically, okay? Then obviously you need to know the URL of that service. So where am I sending the information to? And the request body. What information am I sending? Very important. So this request body is going to change depending on the app or the service that you're using, right? So you need to get well familiar with these request bodies because they vary depending on the service that you're using, right? Then you have the request headers. This is the authorization, right? So in order to send a message, most of the times, you cannot send a message without authorization, without a password or a username, because the service does not know who you are, right? So obviously it's not going to allow you to use that service unless it's free. If it's free, maybe it probably doesn't need authorization, but normally most services already for security reasons need authorizations so that you don't have bots just using the service a million times and then breaking the servers, right? And then you have the response body. That's if you are doing a GET request, right? Mostly. But yeah, study API calls. They're really important, okay? You're going to use them, nevertheless. And then the easier method is webhooks, right? You literally just have a webhook URL, you're sending something, and then you're expecting something back, right? It works slightly different, but it's easier to connect to because you don't need to understand much about request bodies and how the service how the service request bodies are shaped, right? You could essentially send a pretty general request body without any specific structure, and the webhook will receive it, right? Will receive that information without any red flags or anything, right? So here I have a webhook, for example, right? So in VAPI, let's see in VAPI. On functions, it's tools now, isn't it? It changed. But on these, I'm attaching a, let's see if I can use it here. Does it say here? It's somewhere, let me find it. Here, you see? So this is a way to send, this is a webhook, right? So you see it says hook. So I'm sending something to this URL, right? And I believe, if I'm not mistaken, I'm sending I'm triggering, let's see, I can. So what's happening here is that the agent is, the agent, depending on what I ask it to do, right, in the call, it's going to choose one of these, right? One of these tasks, right? Book calendar event, get available slots. And all of these are linked to a separate automation, right? And each of the automations have a individual webhook, a unique webhook, right? So what happens is that whenever I trigger the first one, right, I added here a webhook that is going to trigger, that's going to send some data to that webhook, right? And that webhook is coincidentally the address of this one, right? So the webhook is this webhook address, right? Sorry, just to clarify. So the agent is going to, if it needs to get the current date and time, it's going to trigger this tool, and this tool has a, there you go, has a webhook address attached to it, right? So it's going to send a request to this address, and that address matches this address. So what happens is that I'm going to trigger that, I'm going to trigger this automation, and I'm going to receive also a request body. So that means that I'm going to trigger this, but as well I'm going to receive some JSON object that I can possibly then refer to and maybe add on this language model or add on this Google Sheet, for example, right? So webhooks are a more general universal way of sending data between applications and services, okay? And yeah, if you can use this method, I suggest it because it's much easier, right? Unless you need something very specific or something that, well, this is more for calling services, right? This is more for calling servers like webhook or automation platforms, right? This is for data for SEO, for right, as I said, services, right? Stuff that is behind some software or something, and you get the idea, right? As I said, data for SEO. What is the other one? The API and so on and so on, right? You're gonna usually use these more. And yeah, so this is what I was referring to, anyways. And it's very important, I think, in order to understand these things correctly, and in order to be able to know how to manipulate the data effectively, because there's going to be some cases where you're going to deal with data manipulation inside these automation platforms. I think it's good to understand how that data looks like and what it means to have the data in a certain way, right? And above that, I think learning Python and JavaScript as well gives you the ability to think about problems in just a programmer way, right? If this, then that. So, thinking about specific conditional logic. So if this happens this, then I'm going to trigger this API service, or I'm going to trigger this HTTP request, and so on, right? So it gets you into that mindset of solving problems in a programmatic way, right? Hope that makes sense. And yeah, these are the main things that I think you should learn, right? Variables and data types, statements, if else, list and arrays, very important to manipulate data, and just knowing what parsing data is, okay? Authentication types as well. Really depends on what you're doing, but I really do suggest that you learn this, because you're gonna have to authenticate with stuff like Google, which is a pain in the ass to authenticate with. And yeah, in order to use some of them services, you need to learn how to pass the access token or refresh token effectively. I think you need to do this as well with WhatsApp verification and connected with WhatsApp, unless you're using something like ManyChat, which is slightly easier to use. But yeah, depends on your use case, right? And another top thing is understanding the client's needs and objectives effectively, right? I think learning how to program in Python and JavaScript is going to help you do this, right? You're going to be able to turn what the client needs into kind of a set of tasks that you need to do. But honestly, this comes with practice, right? And when I'm talking about practice, I mean creating architectures, right? Creating flows. So let me show you what I mean. For example, this, right? So you need to be able to learn how to build these. It's not really difficult, right? There's a lot of tutorials out there that show you how to do it. If you want me to teach you how to build these, let me know down in the comments below and I will help you out, right? And I will make a video about it. But I'm not building anything I'm not drawing anything crazy, right? I'm just building a flow on how the conversation or how the tasks are going to happen, right? Within a flow, and how the user is going to interact with all this, within all this, right? I'm collecting, if I'm collecting any variables from any of the options, right? Let's say if I'm connecting to a database, or I'm turning a file or a variable into some format, or I need to be aware of a format. I'm creating a new variable, right? Stuff like that. So you just need to get into the habit of creating these, because it's just gonna make your life so easy. Because if you have these architectures on the side as you build, then you're not gonna have to think too much about how to build it, right? It's already pre-thought. You already thought about it in the background, and you just have to follow the blueprint, right? But as I said, you will get better at these as you practice them, okay? And yeah, just a final statement. Agents are the future because of all what I said before. They're so powerful. They're able to think by themselves. They're able to trigger tools. And then when you bundle all these agents together into a multi-agentic architecture, well, you will be able to replace teams, right? I just want you to understand the importance of that, and the importance on where we are at right now on the adoption of these agents in the market, right? So since they're the future, I think you should definitely act now that there's time and there's people trying to catch up to these concepts, right? And yeah, as I said, they will handle monotonous specific tasks, tasks that connect to software and use text, voice solutions already, right? This is happening with Blend AI and Vapi. And what's going to happen is that we're going to see a big shift on how humans work. We're going to be pushed onto more abstract tasks, right? That agents will not be able to do, like personal relationships, meetings and deals, right? More creative arts, and so on and so on. And that's it. Thank you for listening. And yeah, let me know what you want me to do next, right? Any specific videos on what to build, agents, AI automations, voice agents, anything that you want me to do, please drop me a comment down below and I will answer and I will consider it for a future video, okay? Thank you so much and I'll see you in a bit.